In this lesson, we will learn the four number systems used in computing: binary, octal, decimal, and hexadecimal. We will begin with the meaning of a number system and base. Then we will study decimal, binary, octal, and hexadecimal, their symbols, positional values, and their relationship with binary. A number system is a method of representing numbers. Each system has a base, also called radix. The base tells us how many unique symbols are available. These are positional systems because the value of a symbol also depends on where it appears. There are four important systems here. Binary has base 2 and uses 0 and 1. Octal has base 8 and uses 0 to 7. Decimal has base 10 and uses 0 to 9. Hexadecimal has base 16 and uses 0 to 9 and A to F. Decimal is the number system we normally use in daily life. It is called base 10 because it contains 10 digits from 0 to 9. Each digit has a symbol value and a positional value based on powers of 10. Look at the decimal number 123.45. Positions to the left of the point use powers 10 squared, 10 to the power 1 and 10 to the power 0. Positions to the right use negative powers. This shows why the position of a digit changes its value. Binary is the base 2 number system. It uses only 0 and 1. In digital circuits, one can represent an on or high state and 0 an off or low state. Computers understand information in this binary form. Binary is also positional. Its place values are powers of 2, 2 to the power 0, 1, 2, 3, and so on. Each binary digit is called a bit. Long binary numbers can become difficult for people to read and manage. Octal is the base 8 number system. It uses digits 0 to 7, so 8 and 9 are not valid octal digits. Its positional values are powers of 8. Octal gives a more compact representation of binary numbers. One octal digit can be represented using 3 binary bits because 8 equals 2 to the power 3. For example, octal 0 is binary 0, 0, 0, while octal 7 is binary 1, 1, 1. So remember, one octal digit uses 3 bits. Hexadecimal is the base 16 number system. It uses 16 symbols 0 to 9 and the letters A to F. In hexadecimal, A represents 10, B 11, C 12, D 13, E 14, and F 15. One hexadecimal symbol can be represented by 4 binary bits because 16 equals 2 to the power 4. For example, A is binary 1 0 1 0 and F is 1 1 1 1. So one hexadecimal symbol uses 4 bits. Compare the systems carefully. Binary uses 2 symbols, octal 8, decimal 10, and hexadecimal 16. Decimal is familiar to people, while octal and hexadecimal make long binary values shorter and easier to work with. Note explains that octal and hexadecimal are useful for compact representation of binary values. A long 16-bit binary memory address can be written in a shorter octal or hexadecimal form. The computer itself still works with binary. Let us recap. Decimal is base 10. Binary is base 2. Octal is base 8. Hexadecimal is base 16. Octal represents binary in 3-bit groups, while hexadecimal uses 4-bit groups. Always identify the base and allowed symbols first. Thank you for watching this video. For more computer science revision, visit www.tuitionharbour.com or email at hello@tuitionharbour.co.uk.